In the last video, I ended by talking about the term Augmented Assignment. IntelliJ and PyCharm highlight errors in our code. They also show warnings sometimes to indicate possible problems with our code, even if it compiles successfully. The third thing it can flag up are suggestions. These are ways that we can improve our code, and you should generally pay attention to them. Now that doesn't mean you have to accept them, it's your code after all, but most of the time the suggestions will improve your code and are based on best programming practices. Now I can't show you this particular suggestion, but if you're on a Mac or a Linux machine, most likely when you hover over line 27, it'll say assignment can be replaced with augmented assignment. And I touched on that phrase briefly in the previous section. I mentioned that I'd explain it more later, so let's see what this is all about. Well, augmented assignment sounds really fancy, but it's just a shorthand way of assigning values to a variable. The Python documentation describes augmented assignment as the combination in a single statement of a binary operation and an assignment statement, which is true but not terribly understandable. So looking at the code on line 27 there, guesses equals guesses plus 1, we're performing an addition. We take the value of guesses and add 1 to it. We then bind the variable guesses to the result. Guesses becomes 1 greater than what it was. The addition is the binary operation, binary because it takes 2 operands to work on, and then there is an assignment. So going back to our code, to change this code on line 27 to an augmented assignment, we'll write it this way. So I'm going to comment that line out. On line 28, I'm going to type guesses plus equals 1. And that's shorthand for what we had previously. If you were programming in Java or C++, IntelliJ wouldn't have suggested this change. That's because in those languages, both statements are in fact identical. Their use is just a matter of preference or style. In Python, however, the augmented assignment form only evaluates the assignee, guesses in our example, once. In the other form, where guesses appeared twice, the variable is evaluated once each time it happens, and that's less efficient. Now, I'd admit that the evaluation isn't very complicated here. After all, it's not like we're doing some complex calculation, something like 12 times 850 plus 13 million divided by 18 is obviously going to take a bit of time to work out. So evaluating a variable, what do I mean by that? Well, evaluating a variable basically consists of looking up its value. That's pretty fast and probably takes a small fraction of a millisecond, but doing it twice when you could just do it once is obviously less efficient. If you do that in a loop, going around say 1,000,000 times, you could be wasting a second or more. Now in terms of efficiency, that might not sound bad unless your code's trying to land an aeroplane. A jumbo jet can travel at over 600 miles per hour. At that speed, 1 second represents 1/6 of a mile, or about 268 meters. Of course, if your code's trying to land an aeroplane without slowing it down first, then you've probably got more serious problems than missing an augmented assignment. But hopefully you get the point here. There's also another reason why augmented assignment is more efficient in Python. With our first form, on line 27, Python creates a new variable. It binds that new variable to the result of performing the calculation, then destroys the original variable. Using an augmented assignment, it can perform the operation in place where possible, modifying the original variable instead of creating a new one. Now this isn't always possible depending on the type of object, the variable in question, but it will be done in place whenever possible. Alright, so let's switch back to the code. So IntelliJ suggests that you use augmented assignments in your Python code rather than the longhand version that we used on line 27 because ultimately they're more efficient. The term augmented assignment sounds far more complicated than it really is. The symbol for them is just the binary operator, plus, minus, multiplication, divide, followed by an equal sign. You can see the example there on line 28. Right, so let's create a new Python file. I'm going to call it AA. And I'm going to paste in some code just to save a bit of time in the video. Okay, so there's the code there. Now what I've done is I've added comments to the right of the code to show the results we'll get from each augmented assignment. So it's easy to see that these augmented assignments relate directly to a normal assignment. They're easier to type, and as they're also more efficient, it makes sense really to use them. So let's run the program just to confirm that we get the expected values for x. You can see the values there. Scrolling down, we've got 24, 20 for the various operations, 100, 25, 5. Noting that this one's now float, 25.0, and the last value, 0.0. Alright, so we've seen two binary operations that can be performed on strings, concatenation and repetition. They can also be performed using augmented assignment. So let's actually type in some code here and have a look at that. On line 24, I'm going to type greeting equals good in double quotes. Line 26, greeting plus equals morning. And what I'm going to do there is on line 24, put a space before the double quote. Moving on, I'm going to print greeting, print parentheses greeting, scroll up a bit more, and on line 29, I'm going to type greeting, star equals 5, print greeting. Right, so we run the program again now. You can see the output down the bottom of the screen. Firstly, we get good morning printed out, combination of the word good on line 24 and morning on line 26 using augmented assignment. But then also on line 29, we've used augmented assignment, and you can see we've now got 5 versions of good morning showing on the second line or the last line of output before the program ended. And we saw that as well in the last section, and this is the augmented assignment way of performing both of these things, these two operations, concatenation and repetition with strings. Now there's 5 more binary operations that we haven't looked at for manipulating individual bits, as well as a matrix multiplication operator, but we'll leave them for a later video. So all the binary operators can be used in augmented assignment, and we can see the full list at the operator precedence table, which we've looked at before. Let's just open that up again. Loading a browser, I'll paste in the link in the resources section as well. And it's in section 6.16 near the end of the page, so let's do a quick search for that. Okay, there's operator precedence again towards the bottom. So you can check out the binary operators on this page. And again, all the binary operators can be used in augmented assignment. Alright, so moving on, in the next video, we'll take a break from coding and have a look at the style of the code that we write. See you in the next video.